Hello, everyone, and welcome to LabX's Before You Buy webinar series. My name is Damon Anderson, Technology Editor for LabX. I'll be moderating today's session. To ask a question or leave a comment, simply type your query into the Q&A box located on the right-hand side of your screen, and it will be forwarded to our speakers following the broadcast. Additional resources for this presentation are available in the handout section, also on the right-hand side of your screen. Thank you to Sartorius. Their support allows LabX to keep these webinars free of charge for our readers. The Before You Buy video series takes a deep dive in the essentials of laboratory equipment purchasing with the help of industry experts. Today, we're joined by Sebastian Weber and Julian Haller from Sartorius Lab Instruments, who will discuss understanding the new balance requirements for your QC workflow from USB 41 to USB 1251. The pharmaceutical industry is undergoing significant changes in balance performance requirements. Driven by international harmonization efforts, major pharmacopoeias have revised their guidelines to follow higher stringent parameters. These updates highlight the importance of selecting the right balances for accurate and robust analytical results according to these updates. So in today's discussion, we'll cover a clear and comprehensive overview of the latest updates to balance QC regulatory requirements. We'll look at changes to calibration, performance verification, traceability, minimum weight determination, and safety factors. We'll also explore how to best implement these new benchmarks in your QC workflow. Dr. Haller will initially walk us through the regulatory updates and their implications in the QC lab. Sebastian will then describe Sartorius instrument and software solutions designed to help you navigate this evolving regulatory landscape. So a bit more about our guests. Dr. Julian Haller is team lead metrology at Sartorius and a recognized expert in applied and legal metrology. He has played a leading role in the standardization and digitization of weighing technology. Dr. Haller is actively contributing to the international regulatory committees and is an ad hoc expert for the revision of Chapter 2.1.7 of European Pharmacopoeia. Dr. Haller is the author of numerous publications and white papers on measurement uncertainty, calibration, digital transformation in metrology, and accurate weighing in the pharmaceutical industry. Sebastian Weber is product manager at Sartorius, where he drives the vision for the Cubis software platform, which focuses on innovative digital solutions tailored to the pharmaceutical industry. Sebastian brings deep expertise in enhancing efficiency and compliance through process automation and workflows spanning from laboratory to commercial manufacturing. So, starting off, we'll ask the question, can you provide an update on the current revisions to the lab balance regulatory framework?
As you see, for the four major pharmacopoeias that feature chapters about balances, the United States Pharmacopoeia, the European, the Japanese, and the Chinese Pharmacopoeia, that all respective chapters are currently under revision or have been recently revised. For the USP, both the mandatory Chapter 41 and the optional Chapter 1251 have been revised, and the revision has been published in July this year. It will become official beginning of February 26. For the European Pharmacopoeia, the Chapter 217 was firstly introduced in 2021. It is currently under revision, and it is expected that this revision is published next year. Concerning the Japanese Pharmacopoeia, Chapter 962 has been substantially revised, and this revision has been published in June last year and will become official end of this year. Additionally, 3 completely new general chapters on weighing and balances have been added to the Japanese Pharmacopoeia. Concerning the Chinese Pharmacopoeia, the guideline 9032 has been published in March this year and has become official just at the beginning of October this year. Concerning the regulatory framework, it is quite important to mention that for all the mentioned pharmacopoeias, there are legal enforcements through respective acts, directives, or laws. That means compliance with the requirements of these pharmacopoeias is enforced by law, so it's legally required when medicines or drugs are to be placed on the respective markets.
Perhaps you can provide further insight into the scope of the chapter revisions.
Concerning the USP Chapter 41, it has been already in previous versions explicitly explained that it just applies when a material must be accurately weighed, which is then mentioned as such in a monograph. However, the latest revision explicitly excludes balances used for manufacturing, so this has been just added for clarification. The Chapter 1251, which is just a recommendation, is a recommendation for making all types of balances fit for purpose in analytical procedures. In the latest revision, it is explicitly mentioned that it can be applied broadly, especially together with Chapter 1058 on instrument qualification. The Guideline 9032 of the Chinese Pharmacopoeia applies to balances used in weighing operations for pharmaceutical quality specifications, and it is like Chapter 41 of the USP triggered by the signal words accurately weighed. So whenever in a monograph these words appear, it is clear that the respective guideline has to be followed. The European Pharmacopoeia applies to all balances used for analytical purposes, especially in tests for monograph compliance. However, there are no such clear signal words. Manufacturing balances are explicitly excluded, and it should be noted that the upcoming revision may limit the scope to tests with numerical limits and assays. For the Japanese Pharmacopoeia, the Chapter 962 applies to all testings of drugs listed in monographs. However, the scope is narrowed to cases where metrological traceability is required. If no metrological traceability is required, one of the general chapters that has been mentioned applies.
Can you detail the environmental operating conditions as specified in these updated regulations?
All of the respective chapters give some requirements on environmental conditions. Although the wording and the explicit requirements might vary a little bit, if you follow these requirements, you will be on the safe side. Concerning the temperature should be stable, and direct sunlight as well as heat or cold sources should be avoided. Air humidity should be between 40 and 60% relative humidity, and ideally it should be above 45%. Concerning air currents, drafts should be minimized by using enclosures and windshields. Concerning vibration, the use of anti-vibration tables is recommended, and heavy equipment should not be placed close to laboratory balances. Static electricity effects should be avoided by using anti-static devices like ionizers, anti-static containers, and a sufficiently high relative air humidity. Electromagnetic fields should be avoided, as well as magnetic sources, and balances should be properly grounded. Concerning cleanliness, like for any requirement in a laboratory, of course, the area near the balances should be kept clean, and dust as well as corrosive vapors should be avoided.
Perhaps you can speak about the importance of calibration and metrological traceability.
The latest revision of USP Chapter 41 has put a much stronger emphasis on these topics. There was introduced a respectively dedicated section, like it already existed in the European Pharmacopoeia and the Chinese Pharmacopoeia. In the Japanese pharmacopoeias, there are dedicated guidelines G16182 and G17182 concerning calibration and metrological traceability. If you follow the following recommendations, you will suffice all of the requirements and will be on the safe side. Let a competent provider periodically calibrate the balance. It should be mentioned that worldwide accreditation is accepted as a proof of competence. So if you have an accredited calibration laboratory, periodically calibrate the balance, you will be on the safe side here. The calibration should be performed under conditions representative of the actual use, so there should be no efforts to provide especially good conditions just for the calibration. The calibration interval should be determined based on the risk and the use of the balance. Calibration results should be assessed against user specifications, and this should be done either by the user with the respective proper documentation, or, which is a bit easier for the user, directly by the calibration laboratory on the respective calibration certificate. Calibration should be performed before and after any significant intervention, like an adjustment with an external weight, repair, any opening of the balance's housing, or moving of the balance. Note that leveling the balance and adjustment with an internal weight do not require calibrations before and after, as they are not considered significant interventions.
Can you review the required performance checks as specified in the updated regulations?
All considered pharmacopoeias require periodical performance checks of accuracy and repeatability by the user. The frequency of the checks shall be based on the risk and the use of the balance. And fortunately, the tests themselves concerning the test loads and the acceptance criteria have been finally harmonized over all pharmacopoeias. The accuracy performance check should be done with a weight of more than 5% of the balance's maximum capacity. Our recommendation is to use the biggest single piece weight below the maximum capacity. A calibrated weight shall be used with an uncertainty of less than 1/3 of the acceptance criterion. And note, if you use a weight of class F1 according to OIML R111, and you use the nominal value, this requirement is fulfilled. For the test itself, zero the balance, place the weight on the weighing pen, and record the indication once it is stable. The sensitivity is satisfactory if the difference between the indication and the weight divided by the weight is more than or equal 0.05%. Note that in the recent revision of USP Chapter 41, it has been added that for multiple range and multi-interval balances, this lower test limit of 5% refers to the maximum of the coarsest range, so to the overall maximum capacity. For the repeatability performance check, use a weight of smaller than or equal to 5% of the balance's maximum capacity, but in any case, not less than 100 milligram. Our recommendation is to use the biggest single piece weight below 5% of max, or 100 milligram. For the test itself, zero the balance, place the weight at the center of the weighing pan, and record the indication once it is stable. Repeat the whole procedure at least 10 times, including the zeroing of the balance before each repetition. Calculate the standard deviation S from the indications with a well-known formula for standard deviation. And repeatability is then satisfactory if 2 times the standard deviation divided by the smallest net weight is smaller than or equal 0.10%. I will say something about the smallest net weight in a minute. Note that if the balance has a very good repeatability and the standard deviation is smaller than 0.411 times the resolution, this should be considered as a lower limit value, so replace the standard deviation with 0.41 times the resolution in this case.
Perhaps you can clarify the concepts of minimum weight, smallest net weight, and safety factor.
The minimum weight and the smallest net weight have already in previous versions of the USP and also of the European Pharmacopoeia been different things. But the difference between these two values was not always clear for all users. So in the latest revision of USP, there has been made some effort to further clarify the difference between these two values. The minimum weight is defined as the calculated value based on the performance of the balance at the time of the repeatability measurement, which means it is not constant over time. It can be derived from the acceptance criterion for the repeatability performance check. If you take that equation on the left side and reshape it, it yields that 2 times the standard deviation divided by 0.10% or 2000 times the standard deviation is the smallest weight that still suffices the acceptance criterion. Again, of course, if the standard deviation is smaller than 0.41 digits, it should be replaced with that value. The smallest net weight, in contrary, is a user-defined requirement which usually does not change over time. So how does that work in practice, or what does it mean in practice? Users should define a smallest net weight for the balance as the smallest amount they want to weigh on it. Weighing should then only be carried out down to this value and not down to the respective last defined minimum weight. I will explain that with an example of some simulated minimum weight determinations over time. The minimum weight changes from time to time, each time it is determined due to changed environmental conditions, random variations, or also a change of the balance. If users now weigh down to the last minimum weight that has been determined, for example, in this case, down to this value, if then the next minimum weight determination yields a higher value, it cannot be excluded that in the time between, all weighings between these two values did not fulfill the repeatability criterion. Therefore, the better strategy is to define the smallest net weight for that balance, keep it constant, and consider the minimum weight determinations just as confirmations that the smallest net weight still is bigger than all determined minimum weight values. In the latest revision of USP Chapter 1251, which is however only optional, and the Guideline 9032 of the Chinese Pharmacopoeia, a safety factor has been introduced, and it might also be introduced in the upcoming revision of the European Pharmacopoeia. The safety factor is the ratio between the smallest net weight and the minimum weight. The reason for considering a safety factor is shown again below. You see that some minimum weight determinations yielded values quite close to the smallest net weight. So actually you cannot be completely sure that between two performance checks, the minimum weight did not exceed the smallest net weight. To give you higher security that this was not the case, you can consider the ratio of the smallest net weight to the minimum weight. This will yield respective values, and it is then recommended to define a safety factor where the ratio should not fall below. The USP Chapter 1251 recommends a safety factor of 2, saying that it efficiently mitigates all factors for stable laboratory conditions and trained operators. We do recommend to determine the safety factor based on risk analysis according to a documented procedure, and we are going to provide a respective guideline and support for users on how to determine the safety factor based on a risk analysis.
What are some recommendations and supporting assets that Sartorius offers as guidance for these new requirements?
Concerning the applicability, we recommend to firstly check which balance falls under the scope of which pharmacopoeia. We recommend to check the environmental conditions and approve them if necessary, and our service or application specialists will be happy to support you with these considerations. If your device has features that support stable conditions like isocal, auto-leveling, and motorized windshields, we recommend, of course, to use these features. Concerning the smallest net weight and the safety factor, we recommend to define the smallest net weight that you will weigh on the balance and make it visible for operators, for example, by placing a respective label on the balance. Consider to define a safety factor based on a risk assessment. Concerning the performance checks, we recommend to define intervals for the performance checks based on a risk assessment and to let a competent provider periodically perform additional performance checks, additional to your own performance checks, as independent confirmation. Concerning calibration, we recommend to define intervals for calibrations by a competent provider and also to define tolerances for the calibrations and then either assess them on your own or more convenient for the user to have them assessed on the calibration certificate. Concerning competence and documentation, we recommend to properly train persons on balances and how to conduct performance checks, and to properly document all decisions like the determination of intervals and tolerances and the results of the performance checks. We do provide a lot of supporting assets, and if you check or scan this QR code on the top right side, you will be guided to a right website that will lead you to the respective assets I will show. We have published a lot of white papers which you can download for free, and I would like only to exemplarily show you 3 of these white papers. So for example, you have heard several times now that intervals and tolerances should be determined based on a risk analysis, and we provide a white paper which does exactly that with a functional annex where you can do the risk analysis on your own. We have also published a white paper on generally the use of laboratory balances in the pharmaceutical industry, giving some recommendations. And for example, as well, a white paper on minimum weights according to different concepts and our recommendations for minimum weights for different types of balances. As well, downloadable for free are our generic operating procedures. So for example, as you see here, a generic operating procedure for a performance test according to Chapter 41 of the United States Pharmacopoeia. These generic operating procedures provide a step-by-step recipe how to perform the respective tests, and also provide annexes where you can properly document, for example, the results of performance checks. Our service provides several services, including respective reports and certificates. So for example, from the service you can get a performance test according to Chapter 1251 of the USP and a respective certificate. For example, as well, a certificate according to the European Pharmacopoeia performance check, or accredited calibration certificates in several countries. Last but not least, of course, also our devices feature several hardware and software features that help you to comply with the pharmacopoeial requirements. And for that topic, I would like to hand over to Sebastian, who will give you some detailed explanation on that.
Sebastian, can you elaborate on the capability of Sartorius high-performance balances and software in achieving these new regulatory benchmarks?
The main idea of the combination hardware plus software is we have a high-performance balance hardware that delivers stable, precise results to meet USP 41, and the software puts USP 1251 into action, guiding the user on the balance screen and forthing the right steps in tasks like calibration, but also in the daily weighing, and recording everything electronically for simple and reliable compliance. When we start first talking about the high-performance balance hardware, we should talk about minimum weight and the safety factor. As Julian explained before, minimum weight is the smallest net sample you can weigh and still trust the result. The safety factor is the extra margin you add on the minimum weight on top to be safe. And a high performance balance lets you use a lower safety factor because it's more stable and repeatable. So features that helps you to achieve this are motorized leveling, an integrated ionizer to remove statics, internal automatic calibration, and also a robust weighing cell that reduces drifts at the end. And why did it matter to reduce the safety factor is because it enables you to weigh smaller sample weights. This saves at the end material and time, especially also then when you have very expensive activities. What we know from the pharmaceutical industry, it saves then also money in the end. When we go to the software part, we were asked by the USP 1251 to follow more a risk-based approach for calibration, for routine tests, and also the documentation around. And also here, software can help a lot. So the software, for example, can schedule this task, guide the user step by step on the screen, store the results automatically, and this all in under 21 CFR Part 11 compliance use. So for example, you can configure a good weighing system that it blocks weighing or don't document weights. If the daily test was not done, then guide the user to complete, for example, the repeatability test, and then enable him to resume work. For this and on our Sartorius balances, we have here a concept what is called QApp. So these are very small application what represents a specific weighing task and run directly on the balance and can be operated via the balance screen by the users, and they guide the user through the specific task. They can observe what the user is doing. They can evaluate results and then also create an electronic documentation what is 21 CFR Part 11 compliant. So for example, here you see our USP Advanced QApp on the screen. This screen below here shows a QApp workflow. So the user directly will be guided on the screen to perform the repeatability test in this case. But this USP Advanced QApp also contains all the other needed tests, and he will directly guide it, and the results will be directly evaluated and also recorded. And for the recording, we have also a nice feature here. This is some visual safety factor performance tracking. So you see as a dot all the test results from the past test runs. You can directly see if they are green, they are within the specification. If they become red, they are outside the limits. You see also the limit line here, and then you can directly assess are all my test results within the specification? Are they out of specification, or only some are out of specification? And are they very close to the limit, or are they far beyond the limit? And this also allows you to support your risk-based approach in the end. And you can see with this, okay, my results are very below the limit. I can also reduce the safety factor. Or if I see I have a few results what are out of specification or they are very close to the limit, then I have maybe to think about to put a higher safety factor. So you can also see with this tools, we give you some guidance what helps you to evaluate very easy your balance performance, and based on this also to adjust your safety factor. Yeah, to sum up, this balances like our Sartorius Cubis 2 with our integrated QApp applications turns USP requirements into everyday steps. We have a high performance hardware with all the features, what I mentioned before. We have the integrated and documented workflows with our QApps and with all features for 21 CFR Part 11 compliance. We are ready for the use in pharmaceutical environments. And as a current changes you see here in the pharmacopoeia, it shows also that it's very important that you have a software for your balance that is actively life cycle in order to always meet the latest regulatory requirements. With this, we all reduce risk, save materials, and keeps your inspection ready.
With that, we'd like to thank our guests and for their insight, and thank our audience for attending today's Q&A webinar. The full webinar will be available in the Webinars drop-down tab on the LabX homepage. Thanks to Sartorius, whose support allows us to keep these webinars free of charge for our audience. Have a great day, and we look forward to you joining us again. Thank you.